The National Cooperative Soil Survey is a nationwide partnership of federal, regional, state, and local agencies and private entities and institutions. We work together to investigate, inventory, document, classify, interpret, disseminate, and publish information about soils. Purdue University has long been a part of the National Cooperative Soil Survey. A primary product of the National Cooperative Soil Survey is Web Soil Survey. This is the main means of dissemination of up-to-date soil survey data in the U.S. You can reach the Web Soil Survey by Googling Web Soil Survey, or you can go to websoilsurvey.nrcs.usda.gov and it'll take you to this landing page. There is a quick basic steps shown at the bottom of this, but I'll walk you through the major steps of using Web Soil Survey. So we'll click the green button to get started. So when you start, you reach this landing page, and the first thing you need to do is to define the area of interest, which part of the soil survey information that you want to look at. The soil survey data covers virtually all of the U.S. states and territories, and for many places in very great detail. So we're going to use the Purdue Agronomy Center for Research and Education, or ACRE, as our example. So one way to go to ACRE is to simply click this plus tool up in the upper left-hand corner and click and drag to zoom in successively to the area that you're interested in. So here is Tippecanoe County. ACRE is up here northwest of West Lafayette, and if we zoom in right here, these are the farm buildings for the Agronomy Center for Research and Education, and you can see the field plots here to the north. So that's one way to navigate to your area of interest. We'll zoom back out and we'll look at another way to do that, and that is just to simply enter an address. So ACRE is at 4540 US 52 West Lafayette, Indiana, and if you click on that, it will take you right to ACRE where we were before. Another way is if you have a latitude and longitude from GPS, say from your smartphone or from your GPS device, you can enter the GPS coordinates. ACRE is at 40.4712 degrees north, minus 86.9923 degrees longitude, excuse me. So this is latitude and longitude, and you click view and it zooms right into to ACRE again as before. One final way is to use the PLLS section, township, and range. And so of course ACRE is here in Indiana. You'll have to select Indiana. You know now that the second principal meridian is the meridian against which most of the land in Indiana is surveyed. ACRE is section 4, so you add the 4 without the S in front of it. And township 23 north, 23 north without the T in front of it, and range without the range in front of it, the range 5 west. So we click on that and we get to ACRE. So I'm going to zoom into this area right here. And the next thing that you have to do before you can actually see a soil map is to define an area of interest. And you can do that up here by defining a rectangle, or you can define an irregular polygon by choosing this tool. So we'll just do it simply by defining a rectangle here and choose this these fields here at ACRE. And this hatched pattern now shows where our area of interest is. So to actually see the soil map, you have to click on this tab here. And now the soil map comes up, clipped to the area that you just selected. The map legend is over here on the left, and they're arranged here. These are the map units in this area of interest. Chalmers silty clay loam is the most abundant one in this part of ACRE, and the Toronto Millbrook complex 0 to 2% slopes is the second most abundant. So if you click, if you're interested in, and of course here the map unit symbol is CM, and here you can see the CM, which Chalmers is this large complex map unit, and here's another part of the CM map unit. To learn more about Chalmers, you can click on the map unit name, and it brings up this report with a map unit description. Lots of different things to look at here. Parent material here is less over loamy glacial till. The drainage class for Chalmers is poorly drained. It's a very wet soil. And down here you have other you have flooding frequency, ponding frequency. Chalmers, for example, is in these depressions, so it frequently ponds. And then there's other interpretive groups here, like land capability classification for irrigated and non-irrigated land, and some other factors. So let's look at this Milford. This is only a small amount. Milford silty clay loam pothole, MU. There's a small delineation of it right up here. But Milford is interesting in that the parent material here are clayey lacustrine deposits. So these were small lakes on this glacial till plain that then filled in with deep silty materials, and these are quite clayey and very wet soils in these small depressions. You can also look at the if you click on this Soil Data Explorer tab, it brings up the soil map again, and now you have the opportunity to pick suitability and limitations ratings for a wide variety of different properties. One that's really relevant here in Indiana, if you're building a house in the away from a sanitary sewer, is that you'll have to have a septic tank absorption field. And so we'll click that, and here we can just keep the ratings, and we'll view the ratings for septic tank absorption fields. They're all about the same here. Everything is the same color red. The warning here is about the map scale. You don't want to zoom in too close, because you can over-interpret the boundaries between these different polygons. But here's the table that goes with this map, and it shows that all of the map units are very limited in terms of suitability for on-site waste disposal using a septic tank absorption field. And the reason for that is ponding in most of these, and then also the depth is to a saturated zone, and slow water movement through these soils. These are all very wet soils, and to have a functioning septic system on land like this, you're very likely to have to build a mound system or to get enough well aerated soil to effectively treat your septic effluent. You can also look at soil properties and qualities here, and let's just look at one of these as an example. And let's say that you're interested in the pH using a 1-to-1 soil to water. And if you just pick the defaults here to view the rating, you get an error because you need to enter some depths information. So we're going to say, let's look at the pH from 0 to 10 inches, and then view the rating. So here's our map, and here's our scale here that shows the pHs in these different soil map units. So the Pella silty clay loam in the pothole has the highest pH from 0 to 10 inches, whereas the Toronto Millbrook complex has the lowest. Now, keep in mind that these pHs are estimated pHs. They're not, they're estimated and extrapolated from measured pH data, but the measured data is quite sparse, and so these should be used as guides. If you need to have pH information for soil management, you really need to do some intensive soil sampling and send those samples off to a commercial lab for analysis. If you are interested in, if you have a geographic information system, here you can download data to your computer and work on this data with your own geographic information software. Some of the commercial software uses features like that. And then finally, if you want a nicely formatted report, you can go to this, you click on the shopping cart tab, and this is the title it's going to put on it, but we're going to put a custom subtitle on it. We're going to call this Agronomy, Center for Research and Education, ACRE. And then we're going to click on the checkout here, and we're going to choose the Get Now delivery method. And another tab opens up in your browser, and here's our custom soil survey report. The area of interest is outlined here in this photograph on the first page of the report. There's lots of sort of standard text describing how soil surveys are made and other features about soil surveys. But then if you scroll down to here, you get to the soil map that we were just looking at, and then the table for the legends down here that has your different map units, and then use map unit descriptions. You can save this to your own computer and print it and use it however you see fit. So that's a quick overview of of using Web Soil Survey. One final comment: this is the official updated soil survey information. Some of you may have used the soil survey books that are published on mainly a county by county level, but those books are now considered obsolete, and the most up-to-date and data is available online through Web Soil Survey. So have fun, and you can check out the soil on your own farm or the place where your house is built or where your apartment complex is built on.